Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 935, Knight Dialer. So the chess knight has a unique movement. It may move 2 squares vertically and 1 square horizontally, or 2 squares horizontally and 1 square vertically, like a L shape, right? The possible movements of chess knight are given in the diagram. So see here, so these are the knight's movement, as you know already, right? Now we have a chess knight and the phone pad as shown in the below. Okay, the knight can only stand on a numerical cell, which means it can stand from 0 up to 9. It cannot stand at the star and hash value. Yes, so in button phones, it like this only, there will be a button phone, right? So here a knight is placed. Okay, now given an integer n, written how many distinct phone numbers of length n can be dialed. Okay, you are allowed to place the knight on any numerical cell initially, and then you can perform n minus 1 jump, which means if they have given n is equal to 1, we cannot jump anywhere. If they have given n is equal to 2, we can do 1 jump. If they are given n is equal to 3, we can do 2 jumps. Okay, now jumps to dial a number of length n. All jump should be valid knight jump, which means you cannot jump apart from these numbers, or you cannot jump to this hash value or to this star value. Okay, now as the answer may be very large, written by using the modulo of 10 power 9 plus 7. So this is not a big deal. We can do this. Fine. So see here, if n is equal to 1, which means we cannot jump. We cannot jump. At first, I'll be placing my knight at this 1. Okay, I cannot jump. So there is only one way. There is only one number. 1 is dialed, right? Now I will be placing the knight at 2, and 2 alone will be the dialed number. So like this, from 1 up to this 0, I can place at 10 places. 10 places will be forming 10 different cell number, 10 different numbers, right? Okay, that's why the output is 10. Similarly, if it is 2, then it will be 20, because see here, when I am placing at 0 the knight, I can do only one jump. When the n is equal to 2, I can jump only one time. If I place a knight at 0, then it can jump to 4, it can jump to 6. So these are the two different combinations. If I have at 1, it can jump to 6 and 8. Similarly for 2, 3, 4, 5, 6 up to 9. So there are totally of 20 jumps. Okay, so in your real-time interviews, they will be giving this example 2 and example 1 as your test case, the sample test case, and they will be asking you this kind of problem, and all test cases will be hidden test case. Okay, at that particular time, many will be doing a mistake. Okay, like, hey, n is equal to 1 means 100, then n is equal to 2 means it is 20, then n is equal to 3 means it is 30, n is equal to 4 means it is 40. Just do a multiply with 10 and return it. False. False. That's not the case, because I'll be telling that why in future, okay, in this video. But now just know that it is a wrong method. But when you are in the interview, you'll be doing this, and you don't know in which test case you are failing, and you will be changing the approach either, or you will be frustrated at that time. So my kind request is, whenever you are seeing the problem, always focus on these values, these things, the wordings they are given in the problem, not on the test case. Okay, the sample test case sometimes will be of some test cases that will confuse you. Okay, so always refer these words. Fine. So let's get started. At first, see here, I want to make sure where and all I can go. Okay, from 0 I can go to 4 and 6. From 1 I can go to 6 and 8. From 2 I can go 7 and 9. And still you have doubt how I am going. See here, from this one, wherever I can go. I can either go to 2 steps vertical and 1 step horizontal. So I can go to 4 and 6. Or I can either go to 2 steps horizontal and 1 step vertical, but it is invalid. Here also it is invalid. Here also it is invalid, and here also it is invalid. Okay, or else I can go to this point. Here also it is invalid. Here also it is invalid. Can you understand this? Hey, it is basic chess movement. Okay, so that's the reason why I mapped that 0 to 4 and 6 here. Okay, so similarly I have mapped everything. here for mapping, you can use hash map, but the best thing is you can use the array. Okay, array index for mapping. Okay, because it is from starting from 0 up to 9, right? So index is also starting from 0 up to 9. So just map it. So this is the basic thing you want to do at first. Okay, now how I'm going to find these things? So the brute force approach is just go to all possible combinations and take only the valid thing. That's it. Finish. Which means hey, at first stand at this one, okay, and do n minus 1 number of jumps and check for all possible valid paths. And now place at 2 and check for all possible valid paths, and for 3 also, 4, 5, 6, 7, 8, 9 up to 0. Okay, can you understand this? So this is going to be your brute force approach. So here we are going to use recursion and backtracking. Okay, and prerequisite for this particular problem is you want to know about recursion and backtracking. Okay, as you know, I already posted a playlist focused on this recursion and backtracking. I'll be giving that link in the description. Just go and watch that entirely so that you can understand what is meant by recursion stack, recursion tree, and how the recursion works, the DFS method. Okay, so just go and watch it, then come back to this particular video. Okay, so that you can understand this clearly. That's the main reason behind it. Okay, fine. So see here, for constructing a recursion, what is the first thing I want? The first thing I want is the function. So what are the parameters, the varying parameters I want inside this function? So I want where I am standing, the knight is standing at this particular instance. I want where the knight is standing at this particular instance. For example, if the knight is standing in this 1 or 8 or 9, where I am placing the knight is more important, right? That's going to be the initial part. So I going to the index where the knight is placed as of now. Okay, what is the second thing I want? Second thing I want is number of jumps. Okay, so this is going to be your recursion function varying parameters. Okay, so now second thing, where should I start? What is my initial value? That's going to the second thing, right? Okay, so for this, let us take n value is equal to 2 as they have given in the question itself. Okay, 2 means what it signifies is, listen this carefully, many will be not understanding at this particular point. So listen this carefully. If n is equal to 2, then I can tell you I'll be placing at this 1, the knight will be placed initially at this 1. Okay, or for simplicity, the knight will be placed at this 0. Okay, and the knight will be traveling from this 0 only one time. The jump is only one time, which means I can travel to this 4 or to this 6. So here there are two possibilities. For this 0, there is two possibilities. Again I'll be going to this 1. Let us take any other color. So now I will be going to this 1, and from this 1, where and all I can go? I can either go to 6 or 8. So go to 6 or 8. So here also there is two possibility. So plus 2. So what I'm just telling you is, we want to go to all possible all the things from 0 up to 9 and go for each and every recursion call for again and again. Can you understand this? For example, see here. Let me draw the recursion tree so that you can understand this clearly. So initially, where I'm going to start? I'm going to start from the 0th index, which means, hey, the knight is placed at this particular point, at this 0. Okay, initially. Okay, now what is going to be my n value? N value is going to be 2 because they have given in the question itself. Okay, now from this 2, where and all I can go? Sorry, from this 0, where and all I can go? I can either go to the fourth value. So the knight is shifted to the fourth number, right? I can either go to this and reduce my jump by 1. I jumped initially, right? Or I can either go to 6 and reduce the jump by 1. That's it. Can you understand this? Yes. Now, so many don't know why we are using the recursion. For those peoples, I'm just teaching you. See here, recursion is, we have a main problem. We are going to divide them as a subproblem, such that the tiniest subproblem, okay, that cannot be have another subproblem. Okay, we can find the solution for that particular subproblem so that we can merge all the solution of all the subproblem to find the solution for the main problem. So this is going to be a recursion. Okay, many don't know about this, but still just understand this. So recursion is splitting up the problem into subproblems and finding the solution for the sub problems and combining them to find the solution for the main problem. So this is going to be a recursion. So see here, I have splitted here. The main problem is this. Now I have splitted it into two things. Now understand this. F of 4 comma 1 means what? Hey, you have only 1 as the n value, which means you don't have any number of jumps left over, because they have clearly stated as n minus 1 is going to be the number of jumps. So you don't have any other jumps. So from here I will be returning, hey, you have written 1. What it signifies? So it signifies, hey, you came across the valid path. See here. For this, you can also do like in another terms, like taking the row and column. 0, 1, 2, 3. And here also 0, 1, 2, 3. You can also do like that. But it is clumsy. That's the reason why I mapped every numbers to other numbers, so that always you will be going apart the valid paths. Okay, but if you are doing in this approach, many will be doing this in this approach at first, then they will be modifying the things. Okay, if you are doing with this particular approach, then it will be quite going to the invalid path, then you will be returning 0, but here I will be returning 1 alone. Okay, so if you understand the recursion and backtracking, you can clearly understand this also. Okay, fine. Now similarly here 6 comma 1 means what? 1 refers to you don't have any jumps, so return 1. So here what is the base condition? Base condition is just check whether n is equal to 1. If it is so, return 1. That's it. Don't worry. That's going to be the only one base condition we have. Okay. Now what should I take? In my one of the recursion call it is returning 1. In another recursion call it is returning 1. So they are asked us to find all possible values. So all possible means sum up. So 1 plus 1 means it is 2. So 2 is going to be my not the output. 2 is going to be number of ways of forming the numbers by initially taking the night to 0. Now next thing you want to do for f of 1 comma 2. Okay, next to do for f of 2 comma 2, then 3 comma 2, 4 comma 2, like that, and sum all of them. Sum f of 0 comma 2 plus f of 1 comma 2 plus f of 2 comma 2 up to going up to f of 9 comma 2. So this is going to be your output. Can you understand this? Yes. So this is what the entire recursion method approach. So still many cannot understand, right? So for those people, I'm just writing the n value as 3 so that you can understand clearly. So if n value is 3, so you will be starting from f of 0 comma 3, then f of 1 comma 3, 2 comma 3, 3 comma 3, like that. Now I'm going to draw the recursion tree for 0 comma 3 so that you can understand this clearly, and you can apply the same thing up to 9 comma 3. Okay, so here what are the mapped value of 3? So mapped value of 3 is 4 and 8. So go to 4 and 8. So f of 4 comma 2. Here f of 8 comma 2. Okay, again for 4 where and all it is going. For 4 it is going up to what? 3, 9 and 0. So go to f of here comes 3 and here comes 1, and another thing is 9. So 9 and then 0. Go to 0. Okay. Now similarly for 8, how many things are mapped to 8? For 8 is mapped as 1 and 3. So go to f of only 2 recursion calls, right? So f of 1 comma 1 and f of 3 comma 1. Now here the n value is 1, which means I want to return 1. Here also 1, so which means I want to return 1. Here also it is 1, so return 1. So 1 plus 1 plus 1, which is equal to 3, and here it is returning 1, here it is returning 1, and 1 plus 1, which is equal to 2, and 2 plus 3, which is equal to 5. So 5 is going to be my output for the particular point, this 0 comma 3 alone. You want to find out for 1 comma 3, 2 comma 3 up to 9 comma 3 and add them all, so that it is going to be the result for this particular problem, the output. So this is not the output, it is just the output for this f of 0 comma 3. Okay, now tell me what is the time complexity. So time complexity will be going up to O of, see here, how many things it is maximum, it is 3, right? So it is going up to 3 power n. Okay, going up to 3 power n. So anyway, it is going to be exponential. Okay. Now what is space complexity? It is going to be O of n. So this is going to be the time and space complexity analysis for the recursion method. Now let me show you the code so that we can further proceed with optimization. So see here, it is going to be the Java code. If you want Python or C++, just go and search in the description. There I have given those codes. Okay. Now the first thing I want to map it, right? So for the mapping purpose, I am using the array where 0th index is mapped to 4, 6, 1. The first index is mapped to 6, 8 like that. Okay, up to 9. Okay. Now what I am going to do? I am going to add all the recursion values. I am going to add all the recursion values and I am going to return it. That's going to be the problem solution, right? So for that, see here, long result is equal to 0, and then I will be starting from 0. I am iterating starting from 0 up to 9, and what I am doing, result is equal to result plus, here comes the function call of I comma n, which means first I will be taking 0 comma n, next I will be taking 1 comma n, next 2 comma n, going up to 9 comma n. Okay, and I am doing the mod operation. This mod operation you already know it. This mod will be equal to 10 power 9 plus 7. Okay, that's what I done in this particular point. Okay, at last I will be returning the result. That's it. Okay, now just see this recursion function. In this recursion function, what is going to be the base condition? If n is equal to 1, return 1. That's it. Okay, and then result is equal to 0, and I will be taking all the adjacent values. Right? So if it is 0, then what are all the adjacent values? It is 4, 6, right? 4, 6. So that 4, 6 will be taken, and in this because of this instead of this neighbor, that 4 and 6 will be substituted, and that going to be the recursion call for again. Okay, and n will be subtracted by 1 in the next recursion, right? So I will be taking all this and doing a mod operation and storing in the result. At last I will be returning the result. Fine, can you understand this? Okay, so if you understand this, yes, you can go and solve the graph question also. Try the graph question, because graph question also, there you will be taking the adjacency list or matrix and doing the same steps in a recursion, where you will be adding the visited array like that, visited array and visited matrix. In future I will be starting with the graph playlist. I don't know when, but I will be surely starting graph playlist, but still you don't want to waste your time. Okay, if you understand this particular recursion, this particular recursion tree and recursion stack, and how the recursion works in this particular problem, this solution, then you can try the graph questions. Take a simple question and do it. It will be quite similar to this, but you will be only taking the visited. That's it. So this is going to be your entire recursion. If you submit it, it's not going to be submitted. So let me optimize it. So just take this. Okay. Now what is the second step of optimization? If you already saw my DP series, then you can know that yes. So the second thing is memoization. So which means I'm going to store all the things in my memory. In future, if it is necessary, I'll be releasing it. Can you understand this? So this is going to be the memoization. By doing the memoization, we can save the time complexity. So the second thing is memoization. For this memoization, we can do by using hash map or array. But I suggest you to learn about the array so that you can easily solve by using the hash map. Now I will be showing the array method. By using that, in future you can go and try about the hash map approach. Okay, fine. Now see here, there are very little things you want to do in this particular problem. To convert a recursion into a memoization. Okay, I'll be showing that. What is the first rule? The first rule is you want to design the array. So array may be of 1D, 2D or 3D, right? So here check for the varying parameter. What are the varying parameter? It is one is I, another one is n. So these are the two varying parameter I have. Right? So I want to design a 2D array. Okay, design a 2D array. Now the next factor is what is the size of the 2D array? Okay, so I value will be starting from 0 and going up to where? Going up to 9. So this is going to be the all possible values of I, right? All possible values of I. Either here or inside this recursion call also, the I value will be starting from 0 and going up to n only. Okay, going up to 9 only. So 0, 1, 2, 3 going up to what? 9. So this is going to be the row. This is going to be the number of row. Now how many number of columns should I have? Refer the second varying parameter. It is n. N means n is starting from where? N is starting from the given value of the user, the input, and ending at where? Ending at 1. 1 is the base condition. So it is ending at 2. It goes up to 2. It ends at 1 of the base condition. So in array, all the indices will be starting from 0. So I cannot start the indices from 2. That's the reason why I am starting from 0. 0, 1, 2 going up to where? N going up to n. Now tell me what is going to be the dimension of the 2D array? The dimension of the 2D array is 10 cross n plus 1. So this is going to be the dimension of the 2D array. Okay. Now tell me what is going to be the initial value of all the things. That's going to be the next task, right? So the initial value is something which cannot be yielded from these written values. In this written value, see here 1 is written, here 3 is written, here 2 is written. So I want some value which is not written either of anything. So you can take -1, or you can take null, or you can take infinity, or you can take minus infinity. That's your wish. But whatsoever the value you are taking, that should be the entire table value. If you are taking -1, then entirely fill with -1 like that. Okay. Here let me take as -1. If you want, you can take -2 or -3 because negative value is not possible. Okay, that's the reason I am taking the negative values. Okay, fine. Okay, now what is the next step I want to add here? So the next step is add one more base condition here. If let us take this as a DP array. If DP of I and n is not equal to -1, because here I took as -1. If you took as null, then here also you want to replace as null. Okay, if this is so, then I want to return what? I want to return DP of I and n. Okay, what this line signifies? Hey, if it is already computed, then don't go for the body, just return from the memory itself, so that it will be time efficient. And also here, instead of returning this result, here I want to add one more line to update the DP array. So DP of I and n is equal to result, and then return the result or DP array. That's it. Okay, so these two lines are updating. That's it. Now my code is memoized. So tell me what is the time complexity? It will be O of n, and space complexity will be O of n. So many will be telling me like, why the time complexity is n? Because see here, the time complexity will be going up to 10n, where the constant will be removed. So that's the reason why it is n. And understand this. So this is going to be the time and space complexity analysis. Fine. And similarly, space also, it is because of two things. One is because of the recursion stack, the internal stack. Okay. And another one is because of the matrix. Now again, some people will be arises with doubt. Like, hey, you took like 10 cross n plus 1 as a matrix. No, it is like taking a constant space. This 10 is a constant. So it is also referred as a space complexity of n only. That's the reason why here I put as O of n. Can you understand up to this? So let me show you the code. Then let us go and continue with further optimization technique. Now your job is go and do this using the hash map approach. And my kind request is, before solving this problem, okay, just go and solve any other DP question at first. Then come and solve this. Okay, because why I am telling is this question is furthermore difficult to solve as a beginner. Okay, so I have a DP series, DP playlist. Go and watch that. Then come back and see this. That's my kind request if you cannot understand till now. Okay, fine. Now see here. What is the first step? I want to design the matrix. So 10 cross n plus 1. All the values will be filled as -1. Okay, that's what I have changed here. Other than that, I didn't change anywhere. What is the next step? The next step is I want to add one more base condition. If already computed, don't do anything. Just return that computed value. Okay, and then at last I want to update it. That's it. By doing these things, 10 power n is changed into n as a time complexity. Can you understand this? So 5 lines of code can make your code from the exponential to a linear type. Okay, so it is not 10 power n, it is like 3 power n. Okay, so but it is a exponential. Now it is a linear. Can you understand this? So this is what the memoization means. Memoization means you are storing in the memory. Whenever you are using it, You are just taking out from the memory. You are not going on to compute again by using the recursion calls. Can you understand this? That's what I have done here. Okay, now let me take this and let us now convert into a tabulation. So the next type of optimization is tabulation. Now, what is meant by tabulation? So see here, before, what is the factor for the space complexity? The factor for the space complexity is because of the one of the recursion stack, and another one is the matrix we have used. So now we are going to eliminate the recursion stack by eliminating the recursion. If I want to eliminate the recursion, then I want to go for looping. Okay, so this is going to be the tabulation method. Okay, here also you want to do some steps to convert memorization into tabulation. This is also going to be much more easy. Okay, so see here. First of all, we want to check the base condition, so that we want to check whether we want to change anything in this DP array. So here I am using the catchy. In drawing expression I use the DP, right? So variable name, that's your wish. Okay, now what is my array looks like? It is from starting from 0, 1, 2, 3 going up to where? Going up to 9. Okay, similarly here up, so 1, 2 going up to n. So this is going to be your DP array, right? Let me draw this. Just a minute. So this is going to be your DP array. Okay, and everything is filled with -1 in this memorization technique. Everything is filled with -1 in this memorization technique. That's your wish. You can either fill it with -1 for everything, or you can leave 0 as it is, or you don't want to assign anything. That's your wish. Okay, fine. Now see the base condition. What is the base condition? If n is equal to 1, then I want to return 1, which means what is n is equal to 1? This particular thing. See this white color. This particular thing is n is equal to 1. So if n is equal to 1, then I want to return I want to return 1, which means I want to fill all thing in this particular column as 1. Can I understand this? The remaining part you can either take as 0 or -1, because here we didn't took anything. We didn't took for any operation. We are going to update it. That's the reason I am taking everything as 1. Okay, in the end you can understand this. You can understand this clearly. Okay, trust me. Now what is the second step? The second step is I want to eliminate this base condition which I added in the memorization technique. Okay, now any other thing I want to change in this base condition? No, there is nothing base condition. That's it. The base condition is finished. These and all the body of the recursion. Whenever you enter the body of the recursion, start with the looping. So for this looping, always start from the varying looping to the constant looping. What I mean is, here the varying looping is n. We don't know about the n value, but for I value I can tell you with confidence, I value will be from 0 up to 9 only. So start. So for what is going to be the n value? So n value will be starting from n and going up to where? Going up to 1. So here let me take this as any other thing like num or steps or jumps. That's your wish. That's your variable name. So here where it is starting, it will be starting from n. And going up to what? Going up to 2. So whenever you are writing in a tabulation, just do in a ulta way. Just do in a reverse fashion, which means I will starting from 2 and going up to where? Going up to n. That's it. Okay. Similarly, for I value also. Here it is starting from I and going up to its neighbor thing, right? So here you can start from, like for this I, you can start from 0 and go up to 9. That's it. Okay, fine. Now what is the next step I want to do? So what is the next line? So long result is equal to 0. So this is going to the next line, and the next thing for neighbor is will be just traversing the adjacent of I. Okay, so whichever the for loop that comes inside my recursion, you don't want to reverse its iteration value. Like here I have reversed from 2 to n, right? So like that you don't want to do here. You just do whatever that we wrote inside this recursion itself. Okay, now inside it, result is equal to result plus, here comes DFS. DFS means it is going to be the recursion function. Whenever we appear with the recursion function, right, just like DP, just write DP of neighbor. What are the varying parameter? Neighbor and n minus 1. So instead of n minus 1, write here as step minus 1, because here we use the steps as the representative for n. So steps minus 1, mod, that's it. Okay. After finishing this, after finishing this for loop, this particular for loop, just write dp. After finishing this, dp of I and n is equal to result. Okay. At last, what should I return? After finishing all these things, after finishing all this loop, what should I return? I will be returning, what is the value I am returning here? What is the value I am returning here? I am just, okay, before returning, I want to do these steps, right? So for these things, I am writing here at this particular point. So for I will be starting from where? I will be starting from 0 going up to 10, okay? And then result is equal to result plus, instead of dfs, what should I write? dp of I, and what is going to be the n mod, that's it. Okay. After that, finally return the result, that's it. So these entire things will be first, and these things will be at last, at second. Okay. While taking you to the code, I will be explaining this clearly. You can understand that there. Okay. Now just understand how we are just changing it. We are just seeing the base condition and modifying the dp array or matrix, and then we are just checking the varying parameters where to where, and just reversing it the intervals and doing the for loop. That's it. Okay. Now tell me, what is going to be the time complexity? So the time complexity will be going to be O of n, and space complexity is also O of n, but the space complexity is because only of the matrix we have taken. Okay, fine. Now see this code. So this is going to be your tabulation code. So see here, everything is same, and dp array is initialized, and the first column entirely will be initialized as 1, because n is equal to 1 means we want to return 1. That's the reason I am doing this. Okay. Now I will be starting from 2 and going up to n, and similarly here I will be starting from 0 and going up to 9. Okay. Now sum is equal to 0 initially, and I will be doing all the stuff I have written in the drawing explanation up to here, and here also I wrote the right. Whenever there is a recursion function, recursion call, we want to take the array name and doing the and take the index of the varying parameter. That's it. And at last just return it. Can you understand this? Okay. So still we can further optimize it. See here. So the next step of optimization is space optimization. So for space optimization, we want to check whether we used the extra space or not. If we use the extra space, then we want to space optimize it. Okay. So see here. So how we are going to check whether we used a extra space or not? So see here, listen this carefully. This is going to be important thing. Here inside the inner for loop, I used dp of neighbor and step minus 1. Okay, step minus 1, which means I only want previous column. Here I used step. Okay, so for this inner for loop, I used only of step minus 1 and step, which means I only want previous column and the current column. I don't want the entire columns, which means now I am using 10 cross n plus 1 as matrix. If I use this space optimization, then I can convert this into 10 cross 2 matrix. We want only 2 columns. Okay. So let me proceed. So here I want to add two lines. So see here, first of all, let me take previous and take this as 10 columns. Okay, 10 columns. So instead let me take 0, 1, 2, 3 up to going up to 9. Okay. Similarly for current also 0, 1, 2 going up to 9. Fine. Now what is the next step I want to do? Next step is initialization part. So here I initialize the first column of the dp as 1. Okay, which means here the previous in this previous you want to initialize either you can initialize everything as 1, and in this current also you want to initialize everything as 1. Can you understand this? What this previous means? This previous means my all these 10 rows. Let me tell you, it will be a bit confusing. Just see here, current. Okay, previous means this row, current means this row. Now can you understand? See here, it is of row, but now, sorry, it is of column, but now I am taking 1D array where we only have row. That's the reason I am taking only of 10 rows. Now can you understand this, right? Okay, fine. Just listen this. Everything of this pre will be initialized as 1. Okay, everything of current you can leave as 0 or -1. That's your wish. But we will be having some particular thing at last. Okay, some particular mistake at last. Let us see that mistake also. Okay, for now let me take this everything as -1. Okay, in future I will be telling you what mistake it leads to. Now instead of this thing only, I done here as initializing everything in the previous value as 1. Okay, now just write this for loop and everything similar. But whenever you are seeing the dp of neighbor and steps -1, step -1 means it is previous. So previous of neighbor, instead of that just change like that. And dp of I and step, instead of that change like current of I. Can you understand this? So previous means what? Previous means dp of something, here comes step -1. dp of current means current means it is dp of something, and here comes step. Can you understand this? That's it. And similarly here also, here it is dp of before that. After finishing this inner for loop, I want to reinitialize the previous value in the current. I want to reinitialize the previous value as the current. Okay, so here come previous is equal to current. That's it. Okay, now at last at this particular point, you will be replacing as what? Previous of n. And many will be having a doubt like, hey, I can also represent this as current of n, right? Because here what is it? Previous is equal to current. I initialize the current and previous as same thing. Then why I cannot write as current of n instead of previous of n? Both are same, right? But now it is wrong. Why? Because our for loop is starting from where? Our for loop is starting from 2, which means if n is equal to 1, and you wrote as current of n, what is the current value? It is -1, which means it will be leading to -10. As my answer. So that's the reason why I will be suggesting you to either change all the current value as 1, or always prefer previous of n. Now hope you understand why I cannot use both the things. Okay, either you can change the current value everything as 1 and use both the things, or just keep the current value as it is and just use previous alone. Okay, now if you cannot understand till now, just see this. So let me use the new thing. 0, 1, 2 going up to n. 0, 1, 2 going up to n. Now initially this is going to be my previous and this is going to be my current. My previous is going to be first column and current is going to be second column. By using this previous column, by using the first column, I will be computing the value for the second column. After that I will be initializing the previous as the second column, and current now will be the third column, and finding the result for this third column using the second column. Next I will be changing this as 3, this is 2, sorry, this is 4, then this is 4, this is 5, so that I will be finding the value for the nth column. I will be finding the value for the nth column, and this nth column will be lastly represented by previous and current. Can you understand this? So this is what I done here. Now tell me, what is the time complexity? It is going to be O of n, and space complexity will be O of n, sorry, O of 1, the constant space. Okay, because we are only using 10 cross 2, which means the constant space. Okay, only of 20 space we are using. Fine. So this is how we will be optimizing the recursion by using the dynamic programming. So let me show you the code for that. And also we have another approach, but I'm not going to teach that. So that's going to be matrix exponential approach. Okay, so that approach we can do the things in log n. The time constant will be log n, but I'm not going to do that. So if you are interested furthermore, just go and search for that approach. Okay, now see here, everything is same, everything I taught you, right? So here you want to initialize every pre as 1. If you wish, you can also use current also. You can initialize current value as 1 here. Okay, if you use that, you can use here as current of I. If you don't, you cannot use the current of I here. You always use the previous of I. And another change here, whenever there is a dp of something and then step -1, then you want to change as previous. If it is dp of something and step, then you want to change as current. Okay, at last I'll be just initializing the previous to the current. Okay, at last I'll be finding the answer by using the previous of I, and I'll be returning the total. That's it. Okay, so that's for the everything for this problem. And if you really have any doubts, just comment below. And if you like this video, subscribe to my channel. And if you understood this particular problem, then comment understood, because this is a very big problem, a very hard problem to go to the first, just solve at the first try. Okay, if you understand, just comment below as understood. Okay, that's it. And don't forget to watch all the DP playlist. Go and watch all the DP playlist. So by using that, you can go and solve the weekly contest also. See here, this is also a weekly contest question. Okay, so for that it will be useful. This DP series will be useful, and for the technical HR also it is useful. Thank you.